So far, our select queries have been restricted by the fact that we've only returned results from one table at a time. We haven't been using the power of MySQL as a relational database at all, really. Let's take a look at the way we can combine tables to form complex record sets. As we can see, we have 4 tables in our sample database, and if we take a look at the makeup of these different tables, first of all the customers table, and then the orders table, you'll notice that there are 2 identical field names. The cust ID, which is customer ID, in the customers table, which is the primary key, has the same name as the customer ID or cust ID in the orders table. In another kind of database system, this might be marked as a foreign key. In MySQL, it's not. But effectively, it acts in the same way. What we're looking at is a manner of joining data from the 2 tables together so that we can pull out all the orders, for instance, that a certain customer has made. We can't do that using the simple select syntax that we've used, however, up till this point. What we need to be able to do is to join 2 tables together. A simple way of doing that is to use an inner join, which is probably the most frequently used join in SQL. And we can write that out 2 different ways. One way is to, first of all, we specify the fields that we want. So orders, customer's surname, and orders order date is all that we're going to get back from these 2 tables. Actually, let's say we get back the total of the orders as well. So that's kind of more useful data. From customers, there's 2 different ways we can spell out this particular kind of join. Now this is an inner join, so we can either say inner join explicitly to join the 2 tables, or we can simply use a comma. We're going to use a comma for now. From customers, comma orders, which tells MySQL that we're pulling data from both tables. However, when we specify an inner join like this, we need to also include a where clause so that MySQL will be able to pull out only the rows that are relevant, and also to join up the orders table to the customers table, and so that the join occurs where the customer ID is the same in both. As we can see, the data that is returned from the 2 tables doesn't need the table names in the result set. But by using the inner join, as we've done, we've been able to pull, using quite a complex join, data from 2 tables which we wouldn't have been able to get from one single table. If we take a look at some of the other tables in this database, we'll see that there is an order items table which has 2 ID columns neither of which is a primary key. That's because this table only exists in order to join products to orders. And we haven't looked at the products table yet either. So let's take a look at that. The products contains a product ID, which is the primary key. The reason we need order items table is that many products may fall into one order. But again, we may find another order containing the same products once more. So what we have in effect is a many-to-many relationship. So we need a central joining table in between them, order items in this case, to help us to bring the data together. We'll take a look at the principles behind this in a later chapter in this title. Suffice it to say for the present, however, that this system, using 4 tables for all the data, may require us to create some quite complex select queries. Let's take a look at one of those. We're going to pull the surname, the title and surname from customers. We're going to pull the product's name and the order items quantity. Let's not bother with the title here so that we can keep it simple. We're going to take this data from 4 different tables here: customers, orders, order items, and products. And we're going to specify, first of all, a joining condition for the orders and customers table, and then with an AND, you remember the AND logical operator that we learned about in the last chapter. We're going to use an AND within the where clause. Then we're going to specify a joining condition for the order items and the orders table. Finally, we're going to use another AND to make our where clause include a joining condition for the products and order items tables. Now this is quite a complicated select query, but not exceptionally obscure. It's quite possible that you'll be using select queries such as this within your databases. Let's take a look at the output that this generates. As we can see, each of the customers has been listed, and the numbers of particular products that they ordered, and numbers, when I say numbers I mean quantities, so at a specific time customer Bonnet, for instance, bought 5 magic wands. Now the reason we need such a complicated query to pull all of this data out is that the customer's name is held in one table, the description of the magic wand is held in a products table, the number of magic wands that the customer actually bought was held in the order items table, and the order itself that it all went through on was held in the orders table. So we needed quite a complex query in order to pull that data out. We'll see the reason for separating the data into different tables, as I said earlier, in a later chapter. However, as we can see, our inner join, expressed in this query simply as a comma, is a very good and flexible way to join up tables together to get specific sets of data. We'll take a look at another kind of join in the next movie.